So if an atom donates one electron, it becomes positively 1 charged, or charged by positive 1. If an atom accepts an electron into its outer energy level, it becomes negatively 1 charged, or has a charge of negative 1. Similarly, if an atom donates 2 electrons, it becomes positively 2 charged. If another atom accepts 2 electrons, it becomes negative 2. So let's look at some examples of that. Right, let's get rid of this stuff. Okay, so let's look at our notes. On page 3, I've gone through the dot and cross structure for showing how an ionic bond forms between sodium and chlorine. Now, I'm going to show you, instead of drawing out all the rings, I'm going to show you a shorter way. And it's the way that I prefer. Now, sodium has 1 electron in its outer shell. It's in group 1, or outer energy level. Chlorine is in group 7, so it has 7 electrons in the outer energy level. When we draw structures, you don't need to show the inner electrons. They don't do anything. They're not involved in bonding at all, so we don't care about them. And if we don't have to draw them, you're going to save time by not drawing them. So sodium, 1 electron in its outer shell, or outer energy level, and chlorine has 7. That gets you exactly the same marks as what I had drawn over on the other board, and took me a fraction of the time to do it. And that's what I want to see in your exam. Don't waste time drawing out rings if you don't have to. Now, to show the ionic bond forming, sodium donates 1 electron, so we have our nice arrow, and we form the sodium ion. Now remember, square brackets, and because sodium has lost an electron, it has a +1 charge. Now for chlorine, to show the chlorine ion, or the chloride ion, we have chlorine in square brackets, and fill in our electrons. So the X's are the electrons it had originally, and the dot was the one that came from sodium. Chlorine has 1 extra electron, it has accepted an electron, so it has a -1 charge. And that's what ionic bonding will look like. Now, another thing they could ask here is to write the formula based on ionic bond formation. So as we look at it, the formula for sodium chloride is going to be just NaCl. For every 1 sodium, I needed 1 chlorine to donate that 1 electron to. So you've got 1 of each. Now let's do one where it's a little bit more complicated. And in your exam, this is my preferred way to show it. I prefer it this way. I don't draw out the rings if I don't have to. It's just a little bit, it's more time consuming, and I don't want you to make a mistake if there's any way around it. Okay, so in your notes, let's look at the examples on page 4. So I'm going to go through the examples and you can fill them in as we go. Okay, so draw dot and cross structures showing ionic bonding in each of the following. So the first one is sodium fluoride. This is what's in toothpaste. So the 2 elements in sodium fluoride are sodium and fluorine. So when we use our periodic table to figure out how many electrons are in the outer shell, sodium has 1, fluorine has 7, because it's in group 7. To show ionic bond formation, draw the arrow from sodium to fluorine, because sodium donates 1 electron. And that forms the sodium ion, so square brackets, and the charge of +1, and fluorine, square brackets, and a -1 charge. And if you wanted to write down the chemical formula, you can. You need one of each. So it's NaF. Now, one thing I'll say here, because I don't think it's focused on too much at junior cert. When you're writing the chemical formulas, if you don't put the number in here, it's assumed that there's one of them. So I don't need to write Na1F1. You don't need to write that. That's the same as just saying NaF. Now again, be careful with how you write it. NaF written like that is wrong, because the symbol for sodium is Na, capital N, little a. So it has to be written like that. We'll talk about that in a little bit. Next one. Number 2. Magnesium chloride. So magnesium chloride magnesium is in group 2, so it has 2 electrons in the outer shell. Chlorine is in group 7, so it's got 7. Now, magnesium needs to get rid of 2 electrons, and chlorine can only accept 1. So 1 electron will move from magnesium to chlorine. Now, this chlorine has a stable octet now because it now has 8 electrons in the outer shell, or outer energy level. Magnesium is not happy. It still has to get rid of that 1. So we need another chlorine. And that electron goes to the second chlorine, like that. Now, when we're writing the ions, magnesium, square brackets, has lost 2 electrons. Now up here, sodium lost 1 electron, so it has a +1. Magnesium has lost 2, so it has a +2 charge. Chlorine, that chlorine has accepted 1 electron. So it has a -1 charge. And I'm going to be lazy and I'm not drawing out the second one because I don't have to. Instead of drawing out the second one, if you just put a 2 in front like this, that will still get you the full marks. If you want to draw out the second one, you absolutely can. It's not wrong. You'll get marks either way. So for this one, where you're going to get the marks is showing that there are 2 chlorines and 1 magnesium. That's 3 marks. So your formula will be MgCl2. And the other 3 marks are for showing the charges on the ions. So you've got Mg plus 2, and then each chlorine will have a -1. Now, let's do one that's quite tricky. The third one on the page is my favourite. Aluminium oxide is a fantastically useful substance. It's used all over the place. It's used in white paint to make it white. Now, aluminium is in group 3. So it has 3 electrons in its outer energy level. Oxygen is in group 6. So aluminium needs to get rid of 3, but oxygen can only take in 2. So 2 electrons go to that oxygen. And let's assess and see what we have. That oxygen now has a stable octet. It's got 8 electrons in its outer energy level. Aluminium is not happy, it still has 1 in there. So we need another oxygen to get rid of that. So that electron goes to the second oxygen. Now let's look and see where we are. That aluminium is now perfectly happy. It's gotten rid of the 3 electrons from its outer energy level. So it now has a stable octet. That oxygen has a stable octet. This one does not, because now it has 7. It's got 1, 2, 3, 4, 5, 6, and the one that you move in is 7. It needs another one. And the only place it can get one is from another aluminium. We take 1 electron from here. Now this oxygen has a stable octet. We're nearly there. Aluminium still needs to get rid of 2. There we go. Now, writing out our ions. So for aluminium, square brackets, Each aluminium has lost 3, so it's a +3 charge. I'm going to be lazy and I'm just going to stick a 2 in front because there's 2 of them, which is fine. Oxygen each oxygen has taken in 2 electrons, so it has a -2 charge. And then there's 3 oxygens, so just stick a 3 in front. If you want to draw out all the ions, you can, that's fine. Now my formula. So look at how many of each element we needed. For aluminium, we needed 2, and oxygen, we needed 3. So that's where the chemical formula comes from. Now, I want you to try and practice those yourself and see if you can get your head around moving electrons from one place to another and what charge that will create. I'll show you a quick way. If you're only asked to write the chemical formula, there's a nice cheat way of how to do that, and it's really, really easy and you still get the same marks. You don't need to write this out if you were not asked. Now, one thing I'll say is, when this comes up on the exam, you were asked to draw a dot and cross structure showing ionic bonding. You must have dots and you must have crosses, because when you draw out the ion, it has to be clear in your diagram that these 2 electrons came from somewhere else and they came from the aluminium. If you are looking back through past papers, they were a little bit more lenient with this and they accepted, even if the question said draw dot and cross, if they were both dots, they still gave the marks. They're not doing that anymore. So when you're doing exam questions, be careful and make sure that you are doing them as dots and crosses. The new chief examiner is really strict on this, so make sure that you're following the question. Dots and crosses is in the question, she wants dots and crosses in your answer. And if you don't have dots and crosses, you lose everything. So bear that in mind. Right, on page 5 in your notes, I've put in a little note about transition metals. Now, when you do juniors art science, everybody is fascinated with the middle block of the periodic table, these things here. They're what we call the transition metals. And they're separate to the rest of the elements. They're in their own separate block. We call them the D block elements. Now, in the notes, there's just little bits about them. So transition elements tend to form highly coloured solutions. That's one of their properties. They have something called variable valency. Now, variable valency is interesting because it means, I'm just going to grab a duster, it means that they can have different charges. And the charge that it has, you're going to figure out from the name. So if we have valency is something that will be covered later on when we go back and look at something called valence shell electron pair repulsion theory. I don't want to go into too much detail yet. So it's going to have different charges. Now, in the notes I've given a table with some examples. So one of them is iron 3. You could have iron 3 oxide, for example. That 3 tells me that iron has a charge of +3. So transition metals are metals, so they're going to donate electrons. So that becomes Fe +3. Another one would be chromium 3. So that would be Cr +3. You could have manganese 2. That's manganese +2. You can have manganese 3, which is Mn +3. You can have iron 2, which is Fe +2. And that's what the variable means. It doesn't, like, usually if something's in group 1, it will donate 1 electron. If something's in group 2, it will donate 2 electrons. The transition metals are a little bit different in that this one has donated 2, but this one's donated 3. It depends on what it's bonded to, how many electrons it will have donated. Now, let's have a look at the cheat way for working out the chemical formula. Now, this is something that is going to stand to you all throughout chemistry. And if you're asked for a chemical formula, I don't want you sitting down to figure out charges and moving electrons and wasting time when you're only going to get 3 marks out of it. If you don't need to show the dots and crosses, if you're not asked to show the bond, don't waste your time. And the general rules that I'm going to talk about now also work for covalent bonding, for determining the formula for most things. So now, writing chemical formula. And figuring out how many of each element we have in the formula. Now, I'll be honest, this drove me nuts in leaving cert chemistry. I could not get my head around it. And I would literally have to sit out, do out the ionic bond, and figure it out from there because I just couldn't see any other way of doing it. Let's do the quick way. So, let's do worked example 1 on page 6. Right, so let's look at writing the chemical formula for a compound. Now, this is something that is initially quite tricky because you're like, how many of each element is supposed to be in here? But when you get the hang of it, it applies to all of chemistry. You're going to see so many different chemical formulas in the chemistry course that if you can figure out what the formula is, you're already at an advantage because other people will just learn them off. No. You learn off how to work out the chemical formula, not what the formula is. Right, let's look at the worked example on page 6 in your notes. So lithium fluoride. So step 1 in working out the chemical formula is look at the group that the elements are in and work out the charges that their ions are going to have. So lithium is in group 1. So it has 1 electron in its outer energy level and it loses 1 electron. So it becomes Li+. Fluorine is in group 7. So it has 7 electrons in its outer energy level and it needs to accept 1 more. So it becomes F-. It's taken in 1 electron. Now, step 2 is balance the charges. Now, when we looked at sodium chloride, we had Na+ and Cl-. These charges balance. You have the same number of positive ions as the same number of negative ones. So you have 1 positive and 1 negative. Add the 2 together, you get 0. So the whole compound is neutral. And the same has to be said here. So I must have the same number of positives as negatives. So I have Li+ and F-. Now, to figure out, this one's fairly straightforward because it's just 1 of each. To figure out how many of each you're going to have in the formula, there's a nice way to do it. We have lithium has a charge of +1, fluorine has a charge of -1. Some of you won't like this, and some of you will love this. All you're going to do is you're just going to cross the numbers. The 1 on the negative charge, bring it down to lithium, and the 1 on the positive charge, bring it down to fluorine. So your chemical formula is going to work out as Li1F1. Now, because we don't tend to write the ones in there, your final formula will be just LIF. Now, what I've done there was I got the lowest common multiple for the charges. The lowest common multiple for 1 and 1 is 1. 1 goes into 1 once, and 1 goes into 1 once. So if you prefer to do it as lowest common multiple, fine. I don't. I just would rather look at what the charges are and just swap them over. And that works for every ionic compound, including the polyatomic ones, which are the nasty ones. Okay, let's make it work for something else that's a little bit more difficult. Let's do magnesium chloride. earlier. So again, step 1, look at the group and work out the charges. Magnesium is in group 2, so it has a +2 charge. So group 2, it's going to lose 2 electrons from the outer energy level, making it Mg+2. Chlorine is in group 7, so it's going to accept 1 electron. So it will have a -1 charge. Now let's balance. Let's do it as crossing the numbers first. So I have Mg +2, and I have chlorine -1. So to figure out what your formula is going to be, cross your numbers, bring the 2 down to the chlorine, and bring the 1 down to the magnesium. And that will become Mg, because you brought the 1 down, it's Mg1. Chlorine, you've brought the 2 down to the chlorine, so it's MgCl2. For anyone who prefers lowest common multiple, you've got 2 and 1, the lowest common multiple will be 2. So for magnesium, 2 into 2 goes once, 1 goes into 2 twice. So you get the same thing, I just prefer that one. And that will be your final formula. Now again, you don't need to show the 1, it's not wrong if you put 1 in there, we just don't. And there's loads of those for you to practice and get familiar with. So in the notes, there's loads of them on page 8. Now I'm going to pick another one that is particularly tricky. But again, it still follows the same steps. So on page 8, if we do number 7, so this came up in 2015. And it was question 11A, and this was for 3 marks. Write the molecular formula for the simplest compound formed between germanium-4 and hydrogen. So we have germanium-4 and hydrogen. So, from our transition metals, we know that this is Ge, and it has a +4 charge. Hydrogen is technically not in group 1, but it has 1 electron in the outer energy level, so it will lose 1 electron and become +1. No, it doesn't. It gains 1 electron, become -1. Okay. To figure out what your formula is going to be, bring the 4 down to the hydrogen, and bring the 1 down to the germanium. So it becomes Ge1, H, and we've brought the 4 down, so H4. So your formula would just be GeH4, and that was for 3 marks. And again, if you prefer lowest common multiple, there we go. The lowest common multiple between 4 and 1 is 4. So 4 goes into 4 once, 1 goes into 4 times. That's the same answer. Yeah. Please practice those. It's going to stand to you in loads of different places throughout the course. Now, on page 9, there's a little added difficulty thrown in here.